How would you decide if what you are about to see in the following video is anti-gravity or gravity control? You decide. Is it enough to see something get lighter on a balance, and then to see that something get heavier again? With nothing apparently added or taken away, except energy. What you are seeing right now before your eyes is in fact that. Inside of this plastic container is some kind of metamaterial, which in fact is a throwaway material not many of us think about. The creator of these experiments would simply like to point you to the fact that what we take for granted every single day may in fact contain the secrets that many anti-gravity researchers and physics enthusiasts have all been looking for. So simple, in fact, our minds dismiss it, and we don't even notice it. Perhaps today, what you will see in this video and learn, for some of you, may change all of that forever. Okay, so I have now this jug. There's a little bit of water here at the bottom. The cap is on very tightly, and these jugs they don't leak. I can shake them around, and I can feel the bulging there from the gases, the trapped gases. So 326.4 grams is what this is saying here, and that's what it's showing on the indicator right there. So it's right about on the line. Okay, so we shall begin. This will take a few minutes to warm up. This light, everything is cold in here. It's about 5 degrees in here, 5 degrees Celsius. It's pretty cold. So this will take a few minutes. But keep an eye on this needle here. Will slowly start to move down. And then after a while, after I turn the light off, it will come back up again. I've been doing many different kinds of experiments with this over the last number of months, but I haven't publicly shared them for various reasons. But I feel like this is something that's important and it's not recognized. Maybe that's my fault for not properly explaining this or demonstrating it in my videos. So you see it's already starting to come down a little bit there. So we're taught in school and everything that water evaporates when light shines on it, which is true, and goes into its gaseous form, and then it rises into the sky and cools down, and then it forms droplets and eventually clouds, and then it falls to the ground again. Everybody knows this. It's called the water cycle. But what's not commonly known is that water doesn't just evaporate and go up into the sky because it buoyancy or because of what we're not taught. And what I'm observing here is that there's actually a lofting effect. There's actually seems to be something anti-gravitational about water vapor, that because this is a sealed container, and what's going on inside here is the water vapor is absorbing the infrared light coming from this lamp, and that is exciting different kinds of
vibration and rotation and motion of the water molecules. So the water molecules are absorbing a lot of this radiant energy here. And this, I believe, has something to do with its ability to rise against gravity in an anti-gravitational way. Because you notice there's no significant change in volume here. To have lift from buoyancy, you have to have an expansion. You have to have an increase of volume to displace an equivalent weight of air. So, but that's not happening here. We don't have a balloon that's expanding to create buoyancy. So just have a look here at the surface temperature here. It's reading about 20 degrees with the light shining on it, 25 degrees. So it's not getting super hot or anything. I mean, this is room temperature here. This HDPE, high density polyethylene, is a very common plastic. It's used in a lot of packaging and whatnot. But it happens to have the property of being largely transparent in the far infrared, which means it absorbs far infrared thermal radiation from the surroundings. And water has a very good absorption ability in the infrared band and the far infrared particularly. So it absorbs that, and then when the light turns off, what can happen then is the water vapor inside, which is all excited from absorbing all the infrared, then begins to radiate that infrared out into the environment. And because this material is like a window in those spectrums, then that infrared energy can escape, which accommodates, you'll see, but it will accommodate a pretty quick return to balance here. In other words, it will gain its weight back. Now what I'm going to do is I'm going to shake the jug. I'm going to get my hands on the jug. I'm going to shake it. And this is going to increase the amount of vapor in there. It actually feels quite cool to the touch here. And then probably what will happen is we'll see even more of a drop. It's almost like it shrunk a little bit. Oh, you see? It's like the weight came back. But it's going to drop again as the water vapor, the new water vapor that's now in this space inside, absorbs more infrared light. So we're going to see more of a drop here. So this is like the sunlight here. Heating the water. I'm going to try that again. Okay, so there's where it is right now. I'm going to shake it. See where it settles here. See, it came up a little bit. That's important because it says to me that the colder liquid water in here absorbed the vapors, took the thermal energy that they had, and then because that energy was deposited into the liquid water, Now the vapors in here have less energy right now until they absorb more. And as they absorb more, they become more anti-gravitational. So in this case here, I'm just doing a simple proof of principle. I'm not trying to make the most efficient anti-gravity machine right now, but this is just to demonstrate a principle of the universe. So we'll just see here. We'll just see this should return in a few minutes. And then I've got another demo I want to do. So this right here is just an ordinary cake container, plastic. What I'm going to do is put this egg carton cardboard, it's just paper. I'm going to put it in here, seal her up. The purpose of this is to retain any water vapor that would try to escape out of here. I want to keep that inside as much as I can. And then what I'm going to do is put it on here. All right, so looks like it weighs about 113.9 grams. It is currently balanced there. So what I'm going to try to do is put this other plastic pan over top of it. So just to prevent when the lamp heats, the inside heats the plastic, even though most of the light passes through, but some of it gets absorbed here and heats the plastic. And I know there's the idea that, well, if you heat the material, it's going to cause convection currents, which are going to cause lift, right? So I just want to rule that out. I don't think that's what's going on here, but just for the sake of being rigorous. All right, so I managed to get this plastic cover just over top of this other plastic container inside here, so there's no contact. It's sitting on the balance. It is balanced on the 0 line right now. So I'm going to turn the lamp on. So this will stop convection currents caused by the heating of the plastic material, because it won't be able to go anywhere here, right? So any currents that are rising upwards will be stopped by this material. So there's nothing that's able to influence the weight of the balance related to convection currents. Now you can see right away in there the fog that's building up on the inside container. And that's coming off of this this paper material in here. Is very hygroscopic, so it absorbs a lot of moisture from the air. But if you notice here on the balance, how it is already dropped quite a bit. If I can get in there, you'll see it on the other camera. There, you see that? It's dropped quite a bit. So we'll just give it a nice suntan here for a couple minutes. So there's already a very noticeable drop on the balance. And that this top plastic pan lid here is noticeably warping from the heat, but it's not making contact with the inside container. That's probably lost about 0.5 gram already. Okay, so what I'll do now is again, this is just a demonstration of principle. I'll turn the lamp off, and then we will wait for the weight to come back. I'm going to stop it about here because it's mostly returned, the weight that is. Just for demonstration purposes. So I hope these 2 demos help clear up any misunderstanding, and also hope that they demonstrate that there's something really going on here that's not explainable with conventional physics or understanding of it. And anti-gravitational metamaterials don't have to be sophisticated, it seems. Throwaway paper. The common thread between this and water in containers and plastic containers and stuff is that this contains water vapor. And, well, not water vapor, but, it contains water in by molecular adhesion in these tiny grains and material, tiny grains that make up the paper fibers and everything. So yeah, that's what's going on there, I believe. And when it gets hot, and also got pretty good results with cardboard, fiberboard. I posted something about a fiberboard experiment that lost multiple grams of weight. Yeah, so going back. A few months ago, I was doing experiments with pop bottles, and noticed that with the lids on and a little bit of water in the bottom, that they would lose weight over time. And of course, nobody believed me, and they thought it was just whatever, evaporation or whatever. Who cares? 50 milligrams. But the interesting thing was the pattern of it, the time-dependent pattern, the exponential loss in weight. So what I've come to believe is I actually need to I think I should make a correction for anybody who's kind of been following my work and videos and stuff. I had this theory that something called easy water, which is called short for exclusion zone water, which was discovered by Dr. Pollock at the University of Washington and his associates. So it's this very thin layer of water that forms due to molecular adhesion, it forms the meniscus and stuff, and when you see liquids, so the water sticks to the material, and it forms this very thin layer. And they believed it was a fourth phase of water. And when I came across that, I thought that was probably some kind of state of water that was responsible for this effect. But now, through further experimentation, I believe it has more to do with water vapor. As there's a layer, a very thin layer of water vapor across the surface of the liquid, or of the surface of water, and it contains thermal energy. The surface of the water absorbs thermal radiation from the background in the 8 to 12 micrometer wavelength, or the far infrared. It absorbs that, and the vapor forms across the surface. And what seems to be happening is, or what seems to be the case, is that this water vapor has this property of being weightless or anti-gravitational, or whatever, what have you, right? And so that's what I think is responsible for those effects. And I found that it is a surface area effect. So the bigger the surface area, the more weight loss you'd see, and also the more light. In the case of these heat lamps, or these halogen bulbs, the more infrared energy that's pumped into this vapor layer, or vapor barrier across the surface of water, the more weight loss there will be. And then, following the removal of that source of energy, as it goes back to thermal equilibrium, there will be also, of course, a restoration of that weight. In other words, it'll go back to its original weight. It seems to be set in place or designed by our Creator, that the water would have this property, that it could circulate, rise and fall, and spread over the earth. It's just this aspect of it that's rather unexpected, I guess. It's one of those things where it's like right under your nose, but if you're not really looking for it, you won't see it. I'm sure we've all seen. I noticed this the other day in my coffee mug, the vapors rising off the top, and how in some parts they spun right up very quickly. And I thought, wow, that thing really, it's like a whirlwind. The water vapor just shoots up. And then we see it on a sunny day after a rain shower, the way it rises so quickly off the pavement. Which brings me to the hypothesis that this effect is probably not just related to water, but probably many other substances. But when they evaporate, they form vapors, and the vapors might have this property as well. So that's something else to research further and to experiment with further, such as like alcohol and oils. Another thing I wanted to say about the simplicity too is a lot of these experiments with anti-gravity and stuff, there's so much weird stuff about it, and things that are very, very difficult to reproduce, because the inventors or the creators of it can't communicate their schematics or their designs, or they can't get their device, can't get anybody to reproduce their device or build it or make it work. And this seems to be an ongoing issue in this field. So I think this is something that just about anybody can do, just as a scientific curiosity. Hopefully it stimulates more discussion, more exploration, more experimentation, and more theoretical physics discussions about what might actually be happening on the quantum mechanical level with water molecules and probably many other kinds of species as well, like I mentioned before. So I hope this stimulates new ideas for you. I hope it's experiments that just about anybody can do, and you don't need fancy equipment. You don't need exotic metamaterials. You don't need high power electromagnets. You don't need 100 million volts. So that's what I think is so beautiful about it. Anyways, if you like this content, please support the channel, subscribe, hit the notification bell.